This lesson is entitled Finding Maximum and Minimum Points by Dr. Archie Earl. First of all, you have to be able to look at the graph of a function and find the local maximum and local minimum points. If you look at the graph that we have here, and you have to be able to tell whether the graph is increasing or decreasing in certain intervals. If you look at the graph here, this arrow on the end means that the graph just keeps on going in that direction, and the same thing on the other end. The arrow means that it just keeps on going. So if you look at this graph, if it keeps going, that means that x keeps going to negative infinity. So you have to give the intervals in terms of x. So the first interval would be from negative infinity to 2. That would be the first interval. And you want to know whether the graph is increasing or decreasing in that interval. So from negative infinity to negative 2, as you go to the right, the graph is rising. That means the graph is increasing. You see, so that means in this interval here, from negative infinity to 2, the graph is increasing. The next interval is negative 2 to 0. If you look at that interval from negative 2 to 0, you'll see that the graph is going down, it's falling, it's getting lower and lower. So that means that the graph is decreasing in that interval between negative 2 and 0. So that's what we have here, that the graph is decreasing between negative 2 and 0. The next interval would be from 0 on the x-axis to 6 on the x-axis. Once again, you have to give your intervals in terms of the value of x. So from 0 to 6, as you can see, as I go to the right, the graph is getting higher and higher. So that means that the graph is increasing in the interval from 0 to 6. And that's what we have here, increasing on the interval from 0 to 6. And the last interval is from 6 to positive infinity, because the graph just keeps going to the right. That's what that arrow means. And the x keeps going to positive infinity. So that's the last interval from 6 to positive infinity. And if you look at the graph, you'll see that the graph is falling. It's getting lower and lower. So that means that the graph is decreasing in that interval. And that's what we have there. So that's increasing and decreasing functions looking at the graph. And you can also determine whether a function is increasing or decreasing by looking at the first derivative. If the first derivative is positive, that means the function is increasing in a certain interval. If the first derivative is negative, when you plug in a number in that interval, if the first derivative is negative, that means that the function is decreasing in that interval. Here's an example. These problems are on page 264, and problems 14 through 33, and some of the other problems too. But this example here is number 27. For number 27 on page 264, we're given a function. The function is f of x equals x cubed minus x squared minus x. That's the function. And we have to find x that have horizontal tangents. The value of x on the graph, wherein we have horizontal tangents. Now, if you have horizontal tangents, that means that the derivative is 0 for a horizontal tangent. Remember that the first derivative represents the slope. So if you have a horizontal line, the slope of the horizontal line will be 0. So to find the point of the slope of the x value of the point wherein the tangent line intersects the graph, we have to find the first derivative, set it equals to 0, and then solve it. So that's what we have to do in number 27 first. And when you get the x value of the a maximum or minimum point, which is what that point would be at that tangent line, you use those values, you plug them into the original function to get the f values or the values of y. So that's what we have to do in this case. We have our function, f of x equals x cubed minus x squared minus x. So first we have to take the derivative of the function, the first derivative. So that would be f prime of x. That would be the first derivative. So we have to take the derivative of x squared, x cubed. Take the derivative of x cubed, and I have that over here. The derivative of x cubed equals 3x squared. So we just plug that into the problem here. Well, we'll do it over here. Here you see I've taken the derivative of the left side. Derivative of f of x with respect to x is the same as f prime of x. On the right side, you have to take the derivative of x squared, the derivative of x cubed, derivative of x. So the derivative of x cubed, I did that here as I stated, that equals 3x squared. So that's what I get here on the right side of the equation. I get 3x squared. Then I take the derivative of x squared. The derivative of x squared is 2x. So that's what I get here for the derivative of x squared. And the derivative of x with respect to x is 1. So we get minus 1. So that is the first derivative of our function. And now that we have the first derivative, we have to set it equal to 0, because the slope of a tangent line is 0. And the first derivative represents the slope of the tangent line. So we set it equal to 0, and then we solve it. The easiest way to solve it is by factoring. If we can't solve it by factoring, then we have to use the quadratic formula or some other method. So we just factor the polynomial. We get 3x plus 1 times x minus 2. Then we set each factor equal to 0. For 3x plus 1 equals 0. We subtract 1 from both sides. We divide by 3. We get x equals negative 1/3. For the other factor, we get x minus 1 equals 0. We add 1 to both sides, and we get x equals 1. So those are our critical values. And those are the values of x wherein we have a horizontal tangent line, which means the slope is 0. So from there, we have to set up our intervals and then test each interval, test a value of x in each interval to see whether it's positive or negative. If it's positive, the function is increasing. If it's negative, the function is decreasing. So we need to set that up, and I've done that on the backboard. So my first interval here is from negative infinity to negative 1/3. That's my first interval. And I have to test a number in there. And my next interval is negative 1/3 to 1. And my last interval would be 1 to positive infinity. So I test a number in each interval. So between negative infinity and negative 1/3, there are a lot of numbers in there, but I used negative 1. You can use any number, and your final answer will still be the same. So you can use negative 2 if you want to, negative 10. That would be in that interval also. So I've done that here. I use negative 1. You substitute the negative 1 into f prime of x. That's what you have to do. Substitute the negative 1 into f prime of x. And then, of course, that will tell you whether you have a positive or negative number. If you have a positive number for the answer, it's increasing. If you have a negative number, the function is decreasing. So we just plug it in, and then we simplify, and we find out that it's equal to a positive number. So that means in this first interval, we get a positive number. That means the function is decreasing in the interval from negative infinity to negative 1/2. All right, then we go to the next interval. negative 1/3. Oh, that's negative 1/3 I meant. Excuse me. We go to the next interval, negative 1/3 to 1. And we choose a number in that interval. The easiest one is 0. So that's what I've chosen here. And I substitute 0 into f prime of x. And then we simplify that, and we find out that that equals a negative number. So that means the function is decreasing in this interval here. From negative 1/3 to 1, the function is decreasing. And last but not least, we choose a number in the last interval from 1 to positive infinity, and I chose 2. You can use any number. If you use 4, your final answer will still be the same. So I used 2. I found f prime of 2, and that came out to be a positive number. So that means in this last interval, the function is increasing. So then you can draw a picture of the function more or less. The function is increasing from negative infinity to negative 1/3. So it's going up from negative infinity to negative 1/3, and then from negative 1/3 to 1, it's decreasing. It's going down. So you can draw the graph like that. And last but not least, from 1 to positive infinity, it's going up. So that's how the graph would look. Now, what you have to do, though, you have to substitute the numbers that you got for x, the critical values that you got for x, when you set the derivative equal to 0 and find f of x. If you do that, you get a better picture and a more exact picture of the function. And that's what I've done here. When I substitute 1/3 into the original function, that's what you have to do to find the y value, or to find f of x. You have to plug the critical value not into the derivative, but into the original function. So that's what I've done here. I plugged in the 1/3, and I worked it out, and my answer came out to be 5/27. Then I plugged in the positive 1, and my answer came out to be negative 1. So that gave me a better picture